Welcome to Home Learning. This is computer science and the topic today is hexadecimal. We're going to be looking at different types of hexadecimal conversions from hex to binary, then from hexadecimal, and you'll be doing some conversions followed by some exam questions. As always, the exam question answers will be reviewed by Mr. Barnes. Over to Mr. Holton to explain it.
Hexadecimal then. Let's cover going from hexadecimal into binary. We're just focusing on the conversions in this video. So if you are not sure about what hexadecimal is in general and you're not up on your binary, you need to go watch the separate videos about those two topics, otherwise you'll struggle with this. The first thing I always do anytime I'm approaching any sort of hexadecimal questions is write the numbers down that are available to me in hex. And if you remember from the other video, the trick is really I go from 1 to 9, but then I keep going using letters A, B, C, D, E, F, and then underneath the letters I've got here, I write down the denary values for them. So that will help me remember what each of these letters, what the value is for each of these letters. I would always encourage you to do this. It's very easy to make a mistake if you don't. Let's do some conversions then. We're going to do, let's do 2A. We're going to convert 2A into binary to begin with. And what I should do is draw a line between each of my hexadecimal digits and then get into the habit of doing this 1, 2, 4 and 8. So I'm starting at 1, I'm doubling all the way up to 8. I'm doing that either side of the line that I've just done. And then I ask myself the question, how can I make the number up here are the numbers I have here? So I don't need any 8s, I don't need any 4s, I need 1, 2, and I don't need any 1s. This is binary conversion now, so see the video about that if you need to. Then I'm asking for A, right, A is the value 10, so how do I make the number 10? Well, I need 1 8, no 4s, 1 2, and no 1s. So that's your conversion now. Your answer from hexadecimal into binary is 00101010. Okay, so far so good. Let's go the other way. Let's say I've got to do binary to hexadecimal. Let's try this number. Let's see, I think that will be, yeah, that would be a good one. And I'm taking this a nibble at a time. If you remember, it's 4 bits for a nibble. Then I'm just going to divide this into nibbles, so 4 bits at a time, and put a line again, just straight down for each of the nibbles that I've got there. Same trick. I'm going to do 1, 2, 4, and 8 underneath each of these, and I'm just stopping at 8, starting at 1, doubling all the way up to 8, and then I'm asking myself the question. Okay, I've got 4 plus 2, that equals 6. Nice and easy because that is below 10, so that's just going to be hexadecimal 6. And then here I've got 8 plus 4 plus 2, that equals 14. So what I'm asking myself now, what letter does that equal? I'm looking here, that equals E. So that means the binary I have here is actually the hexadecimal 6E. So that's converting the other way around.
Okay, so now you've heard a bit about it. Now you need to open up the hex to binary conversions and give it a go. It's self-marking, so we don't need to review these answers. Hopefully you got on well with those. You can always go back and try again if needed. Now we're going to look at hex to denary conversions and do the same thing for those.
Hex to denary then. So to be able to follow along with this video, you really need to understand how to do two conversions. So if you haven't already, go and watch these videos and make sure you understand them. They're the binary conversion videos, so going from binary to denary, and the hexadecimal conversions videos, so going from hex to binary. You need to really understand both of them before you can approach this topic. And then just because we're dealing with hexadecimal, I am going to start off, as I always do for hexadecimal questions, and writing all the numbers that I'm going to use for hexadecimal, so that is 0 to F, and then putting any denary equivalents under any letters that I need to. So 0 to 9, then A, B, C, D, E, F, and then underneath A to F, I'm going to put the values, so 10, 11, 12, so on and so on, all the way up to 15. Let's get straight to the conversions then. I'm going to convert 4A to denary. The first thing I need to do is convert it into binary. So I'm going to put a line down the middle like we used to, 1, 2, 4 and 8 either side of the line, and then I'm going to convert each side into binary. So to make 4, I need to have 1 4 and then no 8s, no 2s and no 1s. To make A, which is 10, I need 1 8, no 4s, 1 2 and no 1s. So there's my binary conversion done, 0 1 0 0 1 0 1 0. Now I need to convert this binary number into denary. So I'm going to put 1 2, I'm going to keep doubling all the way up to 128, and then anything of a 1 above it I'm going to add together. So it's 64 plus 8 plus 2, that will equal, well, 74. It's a nice easy one, that one. So that equals 74. So my conversion for 4A into denary is 74. So hex 4A is 74. Another little trick that you can do if you find it easier is that I know that this is the number of 16s that I've got, and these are the number of sort of units I've got, or ones I've got. So I've got 4 16s, I've got A1s, so I can do 16 times by 4, that would equal 64, and then just add 10. Whichever method works better for you, you follow that. But there's two different ones that you can choose from. Right, I'm going to go the other way then. I'm going to have a denary number. Let's start with, let's do 92. Okay, I'm going to go from 92 again all the way into hexadecimal. First thing I need to do then is convert it into binary. So I'm going to start with number 1 over here, keep doubling all the way up to 128. I'm going to work this through and figure out what the binary is for it. So 92 is not greater than or equal to 128, so 0 under that is greater than 64. So I'm going to do 92 minus 64, which is 28, and then I'm going to keep going along and doing that. So 28 is not greater than 32, but it is greater than 16, so 28 minus 16, that equals 12, and I'm going to keep doing that until I've got my final number, which is going to be that, isn't it? 'Cause 4 minus 4 is 0. Okay, so that's my binary conversion. Now I've got my binary, I need to convert my binary into hex. So I'm going to put a line down the middle, so I'm going to take a nibble here and nibble there, 4 bits on either side. I'm writing 1, 2, 4 and 8 each side this time, so I'm not going all the way to 128, that's why I've got the line there. And then underneath I'm going to go 4 plus 1, that is going to be the hex for 5. And then on this side I've got 8 plus 4, so that is 12. So looking up here, that is C, so 5C. So hexadecimal 92 is 5C. There's your conversions.
So again, you're going to open the Google form for hex to denary conversions and give it your best shot. Also, these are self-marking, so we don't need to review them afterwards. So now we're going to move on to some exam questions. Now this time they will be reviewed by Mr. Barnes afterwards. You're going to get 10 minutes to give them your very best go, and then Mr. Barnes will review them and you need to assess your answers. Now we're going to go over to Mr. Barnes, who's going to review the answers. Please make sure you assess these as you go. Over to Mr. Barnes.
Okay, so now you've had a chance to have a go at the exam questions, it's time to go through these, model the answers and see how you got on. So the first question is quite lengthy. It's got a lot of text at the top about HTML and colours represented by 6 hexadecimal digits, the first 2 digits of this, and so on and so on. The quantity of red, green and blue in a shade of purple are given in the table below. Convert each of the decimal numbers into its hexadecimal equivalent. So actually, pretty much all that information at the top is not really needed. If this question is just asking us to turn this decimal number here into hexadecimal and this decimal number here into hexadecimal. So we just need to apply the process of turning decimal or denary numbers into hexadecimal. So the first step, I've got the number 58. So what I'm going to do is just make some notes up here. So I've got 58 and I'm going to make 58 in binary. So I'm going to put 128, 64, 32, 16, 8, 4, 2 and 1. And then I'm going to work it out in binary. So no 128s, no 64s. We've got a 32 which leaves 26. So 16 into 26, that works. And then that leaves us with 10. So let's just double check that. 32 plus 16 is 48. 48 plus 10 is 58. So now we've got it in binary, we can now turn it into hex. So the simple way to do that is a line down the middle. Now write 8, 4, 2 and 1 and 8, 4, 2 and 1. So the first hexadecimal value is going to be 3 because we've got a 1 and a 1 next to the 2 and the 1. And the second hexadecimal value is 10, but we can't write 10, so 10 becomes A. So my answer for green is 3A. Now I'm just going to get a spare bit of paper for the second one because I've run out of space, so just move that over slightly. So the second one I need to do 156, so I'm going to do the same process. So I'm going to write 128, 64, 32, 16, 8, 4, 2 and 1. Okay. And then I need to make 156. So 128 goes into 156 and that leaves 28. So 64 into 28, no. 32 into 28, no. 16 into 28, yes, and that leaves 12. So we've got an 8 and a 4 and the rest zeros. So now we've got it in binary. Repeat the process again. So 8, 4, 2 and 1. 8, 4, 2 and 1. So I've got an 8 and a 1, which is 9, and I've got an 8 and a 4, which is 12, but I can't say 12. So 12, A is 10, B is 11, which means C is 12. So my answer for the second one is 9C. Let's just move back over. So looking at the mark scheme now. Okay, very clearly, 1 mark for getting 1 correct, 2 marks for getting 2 correct. Go figure. So 3A is correct and 9C is correct. 2 marks. Okay. Next question then is, why do we use hexadecimal to represent numbers instead of binary? Okay, so it's only 1 mark, so you just need to state a point. Now, if you think about this example up here, which one is going to be easier to remember, the binary number or the hexadecimal number? Well, I would go with the hexadecimal number because you've got 2 characters to remember rather than 8 digits. So I am very simply going to write hexadecimal is easier to remember. Okay, so let's have a look at the mark scheme. Just push this up slightly. So the mark scheme for this question, first bullet point here, straightforward, easy to remember or to enter or to read. So 1 mark. Other options we could have had, faster to enter, obviously there's less to type in, fewer digits to remember, which is very similar to easier to remember, less prone to error because writing zeros and ones all the time can make it very tricky, and it's quick to convert into binary. Just remember that hexadecimal cannot be understood by a computer. Binary can. So hexadecimal is purely for humans to have a much easier to remember representation of binary numbers. Okay, moving on. So the next question is, convert the binary number into its hexadecimal. So when we're doing binary to hex, we need to split them into nibbles, and I'm going to write 8, 4, 2 and 1 and 8, 4, 2 and 1. So I'm going to write 1, 0, 0, 0, which is the first 4 bits under the first nibble. And then I'm going to write 1, 1, 1, 1, and then just convert them. So the first 4 bits is the number 8. The second 4 bits is 8 plus 4 plus 2 plus 1, which is 15, but I can't write 15. So then I need to think, right, well, A's 10, B's 11, C's 12, D's 13, E's 14, F is 15. So 15 equals F, therefore my answer is 8F. We'll look at the mark scheme in a minute after going through the next question. So now it says convert the hexadecimal number E2 into binary. So all we need to do is reverse that process. So I'm going to write 8, 4, 2 and 1, 8, 4, 2 and 1. So first of all I need to work out what E is. So looking at my numbers at the top, E is 14. So I'm going to make 14 with the first nibble. So we need an 8, a 4, a 2, but not a 1. So that's 14 in binary. Then I need to make the number 2. So 0, 0, 1, 0. Let's have a look at the mark scheme. Just push these up a little bit. So the mark scheme we've got here. So for the first part of the question, we've got 8F. You get 1 mark for the left nibble and 1 mark for the right. So we've got both of them, 8 and F. So we've got 2 marks. For the second one, again, 1 mark per nibble. 1, 1, 1, 0. 0, 0, 1, 0. So 1 mark for that nibble and 1 mark for that nibble. 2 marks. Okay, final question to have a look at now. Explain why hexadecimal is used by computer scientists. So, thinking back to the previous question we did up here, it's very, very similar. Okay, so why would computer scientists use hex over binary? Well, for them, okay, it's easy and for them to convert from binary. And then for the second mark, I can say as 4 bits, or a nibble, represent 1 character in hex. Okay, so remember with an explain question, I've made my point, easy for them to convert, but then I said why? Because a nibble represents 1 character in hex. So let's have a little look at the mark scheme. Just move this up. Okay. So the mark scheme says it's easy / fast to convert from binary. So I can meet that mark point. As 4 bits or a nibble represent 1 character. So that's the second mark. You could also have said it's faster or more reliable to sort of enter right. It's less error prone. Okay, so there we go, 2 marks.
And that's everything you need to know about hexadecimal for GCSE Computer Science. See you next time.